Hello, welcome to Imet New Employee Orientation Training. Today we're going to talk about laboratory safety. My name's Stephen Deck from the University of Maryland, Baltimore, and I'll go over some contact information on the services we provide there. I'm going to do the first section of the training. It's going to cover OSHA's laboratory safety standard, and then following me, Patrick Wolf from our office is going to talk about how you dispose of hazardous waste. With that, we're going to move into the first topic here, which is EHS contact information. Covers the different people in our office that you would contact if you need help. Myself, Steve Deck, I deal with the Occupational Safety Program. Paul Demopoulos is a University Radiation Safety Officer, so if you're working with radionuclides, you call him. Maureen Kotlis is the Director, so if you have any broader issues, you can certainly contact her. Melissa Moreland's the Biosafety Officer. If you're submitting protocols that involve recombinant DNA, it requires IBC review. She's the person that you can contact for that. And then Patrick Wolf provides a lot of the day-to-day services here in the environmental management program on campus. So, like I said, the first standard we're going to talk about, the first topic, is OSHA, the Occupational Safety and Health Administration's occupational exposure to hazardous chemicals in laboratories. It requires several things for an entity to do, the first of which is develop a chemical hygiene plan. We also, if required, would do chemical exposure assessments, information and training, which is what we're doing now, medical consultation, if you do get injured or you need any advice on an exposure, that the chemicals are properly labeled, that everybody has access to information on chemicals, that you know the material you're working with, that each institution has a chemical hygiene officer, and that we document this and we make sure we have all the record keeping in place. So each institution has a chemical hygiene plan. These are the general elements you find in most chemical hygiene plans throughout the country. Covers safe work practices, personal hygiene, chemical transportation, storage, compressed gas cylinders, how you render operations safe if you do need to step out of the lab, equipment, labeling, emergency response, injuries, medical consultation. Each university can go to the following websites if you work at UMBC, Towson, or UMB to get an access to see your chemical hygiene plan. If you could, take a couple moments to review that when you're looking there. Work it before you work in the laboratory. In addition, if you have a particularly hazardous operation, you should develop some site-specific, lab-specific standard operating procedures to make sure all the safety practices are addressed in that. The next section we're going to talk about is the chemical hazards associated with your research. The first and most basic thing with chemical safety is if it doesn't get in your body, it's not going to cause a problem. So we want to make sure we good personal hygiene, storage practices with chemicals so we don't have any potential to ingest even residual material in your hands or that. The most important thing in my mind is inhalation protection, which is your fume hood, that you do all work with volatile organic chemicals in a fume hood. Absorption, simply wearing your gloves, the proper type for the material you're working with, eye protection, lab coat, and then if you do any research where you're using sharps or needles or anything like that, that you take proper sharps protection and you dispose of the sharps properly. So some of the chemicals you find out in the research labs are either suspect or known human carcinogens. So you certainly want to be extremely cautious with them. A laboratory is designed where you can safely work with those. The main thing is to make sure you use limited amounts of them and you use a fume hood and work back at least 20 centimeters when you're using those compounds. Wash your hands afterwards, take your gloves off, then wash your hands and all that stuff. Corrosives, your acids and bases certainly require eye protection, gloves, personal protective equipment. If you're going to use them where they're going to be an airborne exposure, make sure you use your fume hood. If you do have a splash or an exposure to corrosive, make sure you rinse the affected area at least 15 minutes. If it's splashed in your eye, make sure you use an eye wash station. And then I believe you should encourage you to seek medical attention. If there's any concern, at least you can go get evaluated, seen, make sure there's no side effects with the chemical that are that a physician needs to look into. So, and that flammable liquids, from a safety perspective, we consider a flammable liquid one that has a flash point below 100 degrees Fahrenheit. By 100, with a flash point, it means the liquid, once it heats up to its flash point, say it's 80 degrees, once it heats up to 80.1, it'll start giving off some vapor, and if you had a source of ignition, could cause a fire. So obviously we want to keep them away from sources of ignition. We want to be cautious to don't store them in regular refrigerators, especially the ones with really low flash points, because a regular refrigerator is not designed to be intrinsically safe. It has exposed wiring, and there's been cases where there's been fires and small explosions when people have stored research chemicals in those type of laboratories. And also when they're not in use, store them in a flammable storage cabinet. So if there is a mishap in the laboratory, they don't add energy or fuel to that fire. So also oxidizers, it's important not to store them with flammable liquids, so that the two are basically incompatible. They would make a fire more intense and more likely if something happened and they were in close proximity. So we want to make sure we separate them from our flammable liquids. And peroxide forming chemicals, basically your ether and tetrahydrofuran. Patrick's also going to talk about this a little bit later. So for now, we'll just note that when you get them, date them when you get them, when you open them, and then dispose of them within 6 months. And then each laboratory should have a method for how they store their chemicals and make sure that the compounds are stored where they're compatible, and more importantly, that you don't put chemicals next to each other that are incompatible, such as acids and bases, oxidizers, and flammable liquids, and acids with bleach, cyanides, nitrites, and sulfides. All right, in addition, if you get a new compound in, you're not familiar with it, you should take some time to do some research on it to determine its toxicity, its hazardous properties that are involved with that compound. One good source is a safety data sheet. Some of you may have heard them previously referred to as material safety data sheets. They dropped the material off on it due to a recent regulatory change. They'll have information on the name of the chemical. A lot of chemicals have multiple names. Physical data, toxicity, different information on safety, precautions, and stuff like that. A good place to get some basic information on the chemicals. Make sure all the chemical containers are labeled in good condition. You can read them, so if there's an accident and we go in or the fire department goes in, they can quickly identify the material involved in the spill or the release. That also includes if you're transferring chemicals to another container. Put the word in English, if it's acetone, write that out, xylene, and don't use chemical formulas. I know most of you in the lab understand them, but an emergency responder is not going to be familiar with all the chemical name formulas out there. Engineering controls, your number one protection in a lab is from airborne exposures, your fume hood. That's the piece of equipment you use when you're working with chemicals. We come down and test them manually to make sure they work fine. If you're working with cell or tissue cultures, you want to use the biological safety cabinet. These they actually have a filter, and the high efficiency particulate air filter, a HEPA filter. Those type of filters are not designed to capture chemical vapors. So if somebody went in here and did a lot of chemical research in there, it would basically come out and into the lab. So you want to just use these with your cell cultures, and that's what they're designed for. And then the fume hood, that's basically, it actually exhausts directly out the building. That's what's designed for work with chemicals. So some other important safety equipment, the safety shower, they're all around. They're tested periodically. If you need to use one, you simply grab that handle right there, pull it, and a lot of water comes out. And basically, if you're in a situation where you need to use a safety shower, just stay under it until the emergency medical technicians show up. And then also, your eye wash stations, you need to rinse them out at least weekly, otherwise the water gets stagnant, dirty, and if you do need an emergency, you want to make sure you have a clean source of water to flush your eyes out. And it's also important to document it in case we get audited or inspected so that they know that we've been testing that. Some additional items to be conscious of: electric panels. The maintenance people need to get to them. There's also an OSHA standard that says that about not blocking them. They've got to make sure people have ready access to them and they can easily get to them. Compressed gas cylinders, they store a lot of potential energy, and if they fall and break their stem, they can actually shoot down the hallway and cause a lot of damage, so be careful. That's why we want them stored with their valve protection caps on when they're not in use, secured to the wall, and then be careful. Sometimes the caps will get a little tight, to not bang too much, and just be cautious when you're opening them, because they're a potential source of hazard. And also, for each laboratory, it's required to have a laboratory door sign. It's important to have that contact information if something happens off hours, so we can get in touch with you, explain the impact to your research, and we can start that recovery process. And you can go to our website there, get them, and then we'll come down and get them installed. It's personal protective equipment. Make sure you have equipment that is the right size, that you wear your eye protection when you're working with the compounds, your laboratory coat. In the summertime, sandals and perforated shoes are not encouraged. If you have contaminated or damaged personal equipment, please replace that promptly. And then also make sure you remove it when you exit the laboratory. It's not to be worn in public eating areas or in other places. And one of the more important things is personal hygiene. Wash your hands when you're done with your research and before you go out and have lunch. And as I mentioned before, remove your personal protective equipment. And housekeeping, you actually have some pretty clean labs down here. I've been impressed when I walk through, so that's a very important safety practice, in addition to creating a good, safe working environment. So a couple other reminders: if you do work with recombinant DNA, you would fall under the NIH guidelines, the National Institution guidelines. Each of our entities receive funding from NIH, so that triggers their standards. It's not dependent either on whether your funding's from NIH, just because since our institutes each receive it, all recombinant DNA has to be submitted to an IBC and reviewed and approved through that group. So that basically covers that. If you do, like you said, if you work with that, you want to contact Melissa Moreland from our office. She oversees our IBC, and what you'll do is you'll submit your protocol and your safe practices through our website, through Cicero, and then our IBC meets monthly, and then we'll approve it, and then you'll be able to do your research. And with that, I'll turn it over to Patrick.
Afternoon. My name is Pat Wolf. I'm the Assistant Director for Environmental Health and Safety. I'm going to talk a little bit about hazardous waste, medical waste disposal, and a little bit about emergency response at the end. So what we want to talk about first is, what is a hazardous waste? When I talk about hazardous waste, I'm specifically referring to chemicals. I'm not referring to radioactive materials or biological materials or special medical waste. And the EPA set up a standard called the Resource Conservation Recovery Act, which identifies what is and what is not a hazardous waste. And when they did this, they came up with two different categories of waste that they're concerned about. One's called the characteristic waste, and one's called the listed waste. The characteristic wastes are definition-based wastes, where they said, we want to regulate this class of materials as hazardous waste. And they came up with 4 different definitions. The first one is ignitable. And ignitable are all the things that you would commonly refer to as flammable materials. But they're chemicals that have a flash point less than 140 degrees Fahrenheit, which is different than what the OSHA refers to as a flammable material. So EPA is concerned about it if it has a flash point less than 140 degrees Fahrenheit. All chemicals that are oxidizers, any alcohols that are over 24%, and all flammable solids. So some examples of those are listed: ethanol, xylene, a lot of your flammable solvents that you use in your laboratories. The second definition is corrosive, and it's any material that has a pH less than 2 or greater than 12.5. So we're talking about all of our acids and all of our bases. The third definition is reactive, and the reactive chemicals are all those chemicals that don't play well with others. If it's air or water reactive, if it is explosive, has a capability of going boom, or if it's a cyanide or sulfide bearing waste that under corrosive conditions can produce cyanide or sulfide gases. And we have several of those, the water reactive, the lithium aluminum hydrides, butyl lithium, sodium metal, plus anything that has cyanide in it. And the fourth definition is actually a list of constituents. It's a list of 41 chemical constituents that are primarily herbicides, pesticides, and other organics, but there are 8 heavy metals that are on that toxicity characteristic. And they are arsenic, barium, cadmium, chromium, mercury, lead, selenium, and silver. All of the 41 chemicals that are toxic characteristics are concentration-based chemicals. The lowest concentration that is regulated is for the mercury at 200 parts per billion. If it has more than 200 parts per billion, it's regulated, and the highest is barium at 200 parts per million. So if you use any of the heavy metals, and most notably on the toxic characteristic of the organics is chloroform, it would be regulated as a hazardous waste if it's above the concentration. If you specifically want to know the concentration for any of the constituents on the toxicity characteristic, you can go to our website, ehs.umaryland.edu, and find that concentration. So after the definitions were created for the characteristic waste, they said there are some chemicals that kind of fall out of all those definitions that we still want to regulate. And the EPA came up and created 4 different lists. They came up with a P list, a U list, an F list, and a K list. The K list we're not going to talk about because you don't generate any of the chemicals on the K list here. That's process-specific type waste. The P list and the U list are combined together. They're considered the commercial chemical products. And what they are is they are the unused chemicals that you have in your laboratory that if you decide to get rid of them because they're either expired, you bought too much of it and you want to get rid of the excess, or for some other reason you just want to get rid of it and it has not been used, then if the chemical is on the P or the U list, it would be a hazardous waste. If a chemical on the P or U list gets used and becomes spent, or you mix it with other materials, it no longer is regulated on that P or U list. It doesn't make it any less toxic, it just falls out of the regulations for disposal as a hazardous waste. The difference between the P and U list is that the P list is considered the acutely hazardous waste, the really nasty chemicals, and the U list are something a level below that. So they listed the P list because they have some additional management requirements on the P list above and beyond what you're required to do with the U list. The F list is non-specific source waste, and primarily on the F list, we're concerned about the organic solvents that they've listed on the F list. And pretty much all the organic solvents you use in your lab, from benzene to methanol to xylene and toluene, are listed on that F list. But in addition, there's one category on the F list for dioxin and dioxin-bearing wastes that if you have any dioxin or dioxin precursors, you would end up being regulated under that F list. So what do we want you to do with your waste when you generate it in your laboratory? First off, we want you to keep it in your laboratory. If it's generated in the laboratory, it stays in the laboratory. What we do not want is satellite accumulation where you take the waste down to a janitor's office, or you take waste from one laboratory and store it in another laboratory. So if it's generated in the waste, keep it in the, or generated in the lab, keep it in the lab. We want you to store it by compatibility. Same thing we talked about earlier with regards to storing compatible chemicals together. We don't want to store acids with bases even in the waste category. And we want to try and prevent them from spilling. So if you've got a container of waste and it's a liquid, we want you to put it in secondary containment. There is a limit on how much waste you can store in your laboratory. As a general rule, it says 55 gallons of hazardous waste can be stored in your laboratory at any given time. That's not really too restrictive, and we like to see people getting rid of their waste before they get anywhere near to that limit. But one of the exceptions to that is if you're dealing with any of that acutely hazardous waste that's listed under the P list, you have a 1 quart limit in your laboratory. So if you reach either of those limits prior in your laboratory, you have 3 days to get them out of your laboratory and take them to our facility. So if you get to that level, make sure you submit a hazardous waste pickup request. We'll come to your lab, pick it up, and get it out of your laboratory. And the last thing is the chemicals need to be kept closed except for when you're adding waste to or removing waste from the container. If you don't remember anything else I say, this is the most important part of my presentation. The number one cited EPA violation for hazardous waste in laboratories is improper labeling. And what they require on any hazardous waste containers are these three components. They want you to label the containers with the words hazardous waste. Not HPLC waste, not xylene waste. They want it specifically hazardous waste. They want the date the container was initially filled or contents were put into the container. And they want the chemical constituents in English, by concentration if you've got a solution, and without abbreviations, chemical names, or formulas. So if you have a solution and it has xylene, methanol, acetonitrile, and water in it, you're going to list all four of those components out and give me the percentages of each, even if one of them is not regulated. These are some examples of some properly used labels. The labels on the left are actually available on our website where you can print them out. It is a PDF fillable form, so if you generate the same waste stream over and over again, you can actually type into the form, print it out, make multiple photocopies of it, and you only have to fill the form out one time. You'll notice that it has the three components that are in this waste. There was water, xylene, and methanol, and it lists the percentages of each. If you have a container that actually has the original manufacturer's container and you just need to get rid of it, it's always going to have the initial label on it that has the name and the concentration, and all you have to do is add the words hazardous waste and the date. Or if you don't have any labels or you don't have access to our website, there's nothing preventing you from making your own label so long as it has those three components. As far as getting the waste out of your laboratory, on our website, you have a chemical waste removal request form. That chemical waste removal request form comes to everybody on the environmental health and safety staff, and they will receive that notification that you want your waste removed from your laboratory. We visit the building, the Imet building, at least once every week. And so if you submit your waste to us, we will at least be here once a week to remove it from your laboratory. If something happens and you do not see us within a week, there's probably something wrong. We've had some people misfill the form and not submit the required information for us to find the waste. So make sure you completely fill out the form, and we will be here to remove the waste from your laboratory. Some additional information, as Steve mentioned, we want you to label all chemical containers and all containers that you transfer material to. Sometimes those containers end up becoming waste. If a container is not labeled or we don't know what the contents of the container is, then we have to send that container off for analysis before we can have it properly disposed of. Those analyses are highly expensive, and we back charge your laboratory for that cost. So for every sample, it could be upwards of $250 per sample for us to have it analyzed if we don't know what it is. So make sure you properly label your containers. We want to collect all used oil for recycling. The only used oil that we don't recycle is if it's been mixed with a hazardous waste or PCBs. We'll end up calling that waste oil and disposing it as a waste. But any used oil that comes from a vacuum pump, we recycle and make sure it goes back into proper use. Most batteries are a hazardous waste. So if you've got a nickel cadmium battery, if you've got lead acid batteries, if you've got any batteries, silver oxide that have a hazardous component, we're going to dispose of those through proper means. But alkaline batteries are just recycled through Matt Moore, so you can contact Matt to dispose of any alkaline batteries. But suffice it to say, we will collect all chemicals from your laboratory and properly dispose of them, whether they are hazardous waste or not. So if you have chemicals that you know are not regulated and you just need to get rid of them, sometimes it's safer just to give them to us, and we'll make sure they're properly disposed of rather than throwing them in the normal trash. Some information on shock-sensitive chemicals. Ether forms peroxides readily. We mentioned earlier that we want you to date ethers upon receipt, and then once you open the container, get rid of the containers after 6 months and turn it into us as waste so that we don't have a concern about peroxides forming inside of the ether container. Organic peroxides are very shock sensitive when they get warm, so we want to make sure you keep those refrigerated. And picric acid has a tendency to be shock sensitive and explosive when it starts to dry out, so always make sure you keep your picric acid hydrated. Broken glassware. We don't deal with the broken glassware disposal within our office. What we want to do is have you buy your broken glassware boxes in your lab, and you can put all your broken glassware in that box up to and including the chemical containers that have been emptied and cleaned and are not labeled any longer with the original manufacturer's label. The only exception to putting chemical containers into a broken glassware box is that if the chemical container was an acutely hazardous waste or acutely hazardous chemical that is on that P list, we want you to give that container directly to us as opposed to using the broken glassware box to get rid of it, because there are additional management requirements on that container. Just a little bit about waste minimization and pollution prevention. Disposal of hazardous waste is very expensive. And what the EPA put out was that what we want you to do is make less hazardous waste or make less toxic hazardous waste if possible. And there are many ways that we can do that, from utilizing mercury thermometers that don't have mercury in them or that use the alcohol thermometers as opposed to the mercury thermometers. If we have to dispose of the thermometer, it's a lot cheaper and safer to dispose of the alcohol thermometer. If you're using liquid scintillation cocktail for your radioactive material use, if you use a non-hazardous liquid scintillation cocktail, we can dispose of that a lot easier. So the whole goal is to make less waste or less toxic waste if you have the opportunity to do so. As far as emergencies in your laboratory, if you spill a chemical in your laboratory, we want you to take the opportunity, if you did it and you have the capabilities of cleaning it up yourself. If you do that, there's some steps we want you to take. We want you to don the appropriate protective equipment. If the safety data sheet says you must wear a respirator, you should wear a respirator. If it says wear gloves, we want you to wear gloves. We want you to control the source of the spill. Whatever is spilling, make sure you don't spill any more than you absolutely have to. Control the spill from going down the sink drains, underneath the bench tops, going into floor drains and the like. Absorb any of the freestanding liquid or clean up any powders that spilled. Label what you cleaned up as hazardous waste and provide it to us for disposal, and then restock your spill supplies. If you don't have the ability to do that, or you don't have the proper equipment to do that, what you're going to want to do is call Matt Moore at his phone number and call 911 and bring Baltimore City Fire Department in to help you clean up that spill. Talk a little bit about special medical waste disposal. You don't generate a lot of that in the building, but you do have some cultures and stocks of infectious agents, and you do have some animal waste that's been exposed to infectious agents. The human pathological and blood is not too common in Imet, but we do also have a lot of sharps that come out of the building. If you generate special medical waste, if you have sharps, we want you to use an approved puncture-resistant, leak-proof sharps container. We do not want you to makeshift your sharps containers and use coffee cans or milk jugs. Make sure you use an approved sharps container. If you generate contaminated labware or other special medical waste, you can either put that into the biohazardous waste boxes that we do provide, or if you're using an autoclave and autoclaving the waste, you put it into an autoclave bag. We don't provide the autoclave bags, but if you buy your autoclave bags, autoclave the waste, and you can put the autoclave waste directly into the gray carts that are sitting in each autoclave room in each floor of the building. We don't want you to have chemical or radioactive materials in any of these containers. If you have any of that, you would dispose of that directly through us. If you generate animal carcasses, what you want to do is make sure you double bag and freeze your animal carcasses. We will transfer them from your freezer to our freezer and dispose of them at our facility. Any questions?